Hey everyone, here's our math problem for today. Find the values of these two complex expressions. Number one is ln of I, and number two is I raised to I, where I is equal to the imaginary unit square root of -1. You can pause the video and see if you can find the values of these two very important complex expressions. Now let's solve this problem together. Let's begin with number one. What's the value of ln of I? In order to find the value of this expression, let's begin by visualizing in the complex plane. The horizontal axis is the real axis and the vertical axis is of course the imaginary axis. Let's locate any point and let's call it as point Z, and that can be expressed in polar exponential form as the radius times the natural number e raised to exponent I times the angle. This means that if we connect this red point to the point of origin, the length of this line segment is r, which is the absolute value of z, also known as the modulus. Then, if we take the angle of this red line with the positive real axis, that is this angle theta, which is this theta. This angle is also known as the argument of the complex number. Now, since we're looking for the natural logarithm of I, let's take first the natural logarithm of any complex number z. So taking the logarithms of both sides, we have the natural logarithm of z equals the natural logarithm of the right side r times e raised to I times the angle. Notice here that we have a logarithm of a product, and the logarithm of a product is equal to the sum of their respective logarithms. And so we now have ln of r plus ln of the quantity e raised to I times the angle. Now the beauty of this is ln and e are inverse operations that can cancel each other out. So let's remember this result. We want the ln of I. So let's visualize where is I. If we have here a distance of 1 unit from the point of origin going up in the vertical axis, which is the imaginary axis, we have the imaginary unit I. And that is equal to the radius of 1 unit times e raised to the angle. And this angle theta is the angle we form here, which is pi over 2, this pi over 2 here. And if we rotate every 2 pi, we are going to go back to the same point. That's why we have plus 2n pi, where n is an element of the set of integers. Now going back here, if you now take ln of I, that is equal to ln of the radius of 1 unit plus the ln of e raised to I times this angle. The angle is this angle. What is the natural logarithm of 1? In other words, e should be raised to what number in order to get 1? The answer, of course, is 0, because any number raised to 0 is equal to 1, and we just copy this second addend. Now, let's compute now for ln of I. ln of I is equal to this formula here, ln of e raised to I times the angle theta. And we said the angle formed of I with respect to the positive real axis is pi over 2 plus 2n pi. And ln and e are inverse operations, so the right side is simply the angle I times the quantity pi over 2 plus 2n pi. And this is now the value of ln of I. And if we take n equals 0, we have ln of I is equal to I times pi over 2. And we call this value as the principal value if we limit the domain of the angle from negative pi over 2 to pi over 2. And this happens when n is equal to 0. And most of the times when you compute for the value of ln of I, you are more interested with the principal value. But generally, this is the expression for ln of I, and the principal value of ln of I is I times pi over 2. We need this result in order to answer our second problem. So let's go to the second problem. What is I raised to I? Again, let's recall that a number x is equal to e raised to ln of x, because e and ln are inverse operations that cancel each other's effect, so x equals x. Similarly, if x equals I, this is just the same as e raised to ln of I. Again, e and ln will reverse each other's effect, leaving us with I. We have here this pink colored I, and we have this value for that I. So by substitution, we now replace this pink I by this result here, and we just copy all the rest. Now, let's recall that ln of I has a principal value of I times pi over 2. That means we can replace this exponent here by this principal value, or we can replace it with this general solution for ln of I. And so by substitution again, using the principal value, we have e raised to I times pi over 2. And applying the power rule of exponents, we multiply the inner exponent times the outer exponent. And we arrive at I squared times pi over 2. But I squared is equal to negative 1. And so, finally, we have I raised to I is equal to e raised to exponent negative pi over 2 plus 2n pi. We have here a constant e, we have here a constant pi. I raised to I is equal to the transcendental number e raised to the negative of another transcendental number pi divided by 2. And this has a value of approximately 0.20788. So an imaginary number raised to another imaginary number resulted to a real number. That's how crazy the complex number world is. And so going back to our main questions, for the first question, the ln of I is equal to I times the quantity pi over 2 plus 2n pi, and I raised to I is equal to e raised to negative pi over 2, which is approximately equal to 0.20788. But since this is a multi-valued expression, you can also get its value by replacing the angle by multiples of 2n pi. You just let n be equal to 1, 2, 3, 4, and compute the corresponding value using this formula. And so, we are done.